Hello and welcome to another video. In this video I will show you how to add a potentiometer to the ESP32 to read its values on the Pi, and then we'll add an LED to the Pi to adjust brightness levels, just like we did with the Pico W. I will show you the code and show you how it's similar and different to the Pico W. Let's get started. Alright, let's get started. Now, I should note that this video will be accompanied by a Medium article, which I'll link in the description. Now, if you have the setup as before, you don't need to worry about it. You're ready to go. Now, if not, I'll just link the video above so you can reference it. And it's the video from the first video of the previous tutorial, which will apply to the Pi. But in a nutshell, you need to install Bleak in a virtual environment inside the Pi. Now, if you're using the desktop version of Bookworm, then you're ready to go. You have everything. If you're like me and you're using the light version, you'll have to enable remote GPIO. You'll have to install Pi GPIO through pip. Now, if you're on the Pi 5, you'll have to use apt. And the same thing with GPIO 0. Apparently, there's something going on with the RP1C0 chip, so be sure to keep that in mind if you're using a Pi 5. On the ESP32, you just need to install the AIO BLE libraries, and I did this inside of the lib directory, which you can create on your own. But that's really it. It's all the setup you need to do. Now let me show you the wiring diagram. It's kind of big, so I apologize for that. Yes, I used two breadboards. Well, in my case I didn't, but in this one I did. As you can see, I have the ESP32 here. I have one leg of it connected to 3.3 volts, the middle leg connected to pin 13, and ground, of course, connected to ground. Then, of course, I have ground, which is going to be connected for the LED. So, for the Pi, there's common ground. This will be connected to pin 17 for the LED that we are going to blink. And then for the other one, it's for the brightness, which is pin 27. Other than that, that's really it. There's no other thing we need to do. Let's get to the code. So on this code, BLE it's pretty much the same. We just added ADC. We need to define our potentiometer at pin 13. And we need to add this to enable it. Everything else still stays the same. But on here, we read the potentiometer value, and then we have that as our message, and then we have our message, which is encoded as a string, and then we write the message, and then we do a 0.1 second sleep, and that's it. Everything else still stays the same. Now, on ESP32 Connect, it's pretty much the same. Everything is still the same. The libraries, we have our variables, we have the MAC address of the ESP32, and that's really it. Everything else stays the same, except on receive, I changed the delay to 0.1 seconds so that it can match the other one. But yeah, there's really nothing else to do here. And then on ESP32 pots, the only thing we added is another LED, which I call green, except this is PWM LED, which I had to import here. Everything stays the same, except I had to do this. Now, as you can see, I added a variable called norm with a max of 0.0 and min of 1.0, and then when we take x, which is our response message, and then divide by 4095.0, because that's how far the potentiometer can go. And then the value of the PWM will be based on the norm. So it will give us values from 0 to 1. And that's it. Other than the delay, that's it. We are ready to go. So as you can see, if you compare the code to the Pico, it's pretty much similar, except we don't have the Pico 0. And also, we had to add calculations here. On the Pi side, it's pretty much the same, other than that we had to define the UUIDs in a different way. Everything else is pretty much the same. So there's not much of a difference between the Pico and the ESP32 and how we set things up on the Pi. But yeah, there's not much difference. So I think that's a good thing. So I'm going to first run the regular demo with no LED and then the next demo with the LED. So let's go. Alright guys, so here we are with the first demo. We're already connected. Now watch as I move the potentiometer. Look at the values increase. Yes, you can add features to prevent debouncing, but I decided not to do that in this case. And you can see it's already gone up to 4095. Now let's go back down. Look how it's done. Now I can increase the delay if I wanted to make it a lot more stable, but this works as a proof of concept. And let's get to 0. And there we go. We got to 0 just fine. So let's exit this code. And that's it. So let's get to the next demo right away. Hey guys, it's the next demo, and as you can see, I have everything set up. I have the LED blinking. So let's change the value. So as you can see, look how it goes up. Full brightness. Now let's decrease it again. Low brightness. So it's essentially no brightness. So there we go. We managed to get it to run exactly like we did with the Pico W, just with some small changes. And here's the setup. Yeah, it's not very good, but it gets the job done. So that's it for this quick demo. Well, that's it for this video. And as you can see, it's very similar to what we did on the Pico W. In the final part, we'll do the same by adding button control. And in the future video, I will show you how to build a robot controller using an ESP32. Take care.